Okay, so this is going to be my attempt on Doceri to make you guys a video. I tried to get the document camera to work so that you could see it actually being written on paper, which is much clearer, versus using Doceri. But I will do the best that I can on here. Just kind of know a lot of it I have to write with my finger, which actually comes out a little clearer than it does with the stylus. So. Alright, so you already have the definitions of a vector, its initial point, terminal point, magnitude, which is the length of the line, the different ways that you can write it. So we're going to be writing a lot in standard point. So a standard point, let's say, like regular parentheses, A, comma, B. Okay? Well, if you're writing it as a vector, it's not a parenthesis and it's not a less than or greater than sign. It's kind of it goes more like that. A, comma, B. Right, those are kind of something like that. So just kind of know when you guys are going to be doing that, that's what it's going to look like. Alright. Alright, so to go through with a vector, you want to go through, and oftentimes you're going to change it to this standard position. Remember this right here. That right there is your standard position. Okay, so there's our standard position. We're going to go through to get something to standard position. Let's say its initial point. So, initial point. I'm so sorry. Your initial point, let's say, is at x1, y1. And your terminal point is where it ends up. So, let's say our terminal point's at x2, y2. Well, in order to find our standard position, all we do is we just go through and subtract our terminal minus our initial. So we just do x2 minus x1, and then comma, y2 minus y1. And that will be our standard position. So we're going to go through and look at a couple examples of this, as well as be able to go through and graph them. So let's say that we have, and this is your first couple problems in your homework if I remember right. Let's say your initial point. I'm just going to put IP for initial point so that I don't have to keep trying to write it. But let's say my initial point is at 2, 3. And my terminal point is at 6, 4. Well, if I want to go through and find, our standard position, of our vector, all we got to do is go through and do our 6 minus 2. So 6 minus 2. And then we do our 4 minus our 3. Okay. So our vector in standard position would be at 4, 1. Now, if we wanted to go through and graph it, which somebody asked me earlier about number 6 and number 8, I think, in the homework, you don't have to go through and graph them. Just find your vector. So basically what you're going to be doing is you're going to start at the origin. It's kind of where you, let's not really do an origin point. Sorry. There we go. Point at the origin. And basically I have to go 4 spaces this direction and 1 up. So it's going to put me right there. And the vector is going to have the arrow end right at the point where it's at. Okay? So we'll do one more example of that. So let's say I have one where my initial point is at negative 3, 2, and my terminal point is at 4, 5. Right, so again, what we're going to go through and do is subtract our terminal point x minus our initial point x. So 4 minus negative 3, and then our terminal y minus our initial y. So 5 minus 2. Well, 4 minus negative 3, which is 7, and 5 minus 2, which is 3. So there's our standard position vector. Again, those are not 7s, by the way. I'm very sloppy writing, but either way. Again, if we wanted to go through and graph it, we would start at the origin. We have to go 1, 2, 3, 4, 5, 6, 7, and up 3. Should put us over here. Come on, let it work. It's going to have to go to right to that side. Okay? So hopefully that kind of helps you out a little bit. Alright, moving on. So we want to be able to find the magnitude and direction. Okay, remember the magnitude is your length of it. So let's say that we have, a vector that's at A, B. Okay. Now your magnitude there it is. Sorry. Your magnitude, your symbol for it is kind of like absolute value bars around it. And your magnitude or your length is the square root of your a squared or your x value squared plus your b value or your y value squared. Okay, so that's how we're going to go through and find our magnitude. If you want to find the direction, so direction, it's basically what it is that the angle, so let's see that, it's your angle formed, not frommed, jeez, sorry, formed by the x-axis. Sometimes the y, it just kind of depends, and basically what you're doing is, because if you're looking at the graph of this, I'm going to write up here in this part, okay, if you're looking at your graph, okay, there's your vector, there's your angle, okay, and what we're trying to do is we're basically trying to figure out the angle to it. Well, if we're trying to find this angle, we're using this side, if I can write it, and we're using this side, okay? So basically you're dealing with an opposite over here, and you're dealing with an adjacent, which is tangent. So that's why it's the tangent of whatever angle. And we actually know what our x and y is from the vector, okay? There's our y value, and there's our x value, or in this case, my a and then my b if I'm looking at my traditional ones to it. Well, all I do is do my opposite over adjacent, so that's why your tangent's going to be equal to your y over your x, or in this particular case, which is our b value over our a value. And remember, to find that actual angle, we do the inverse tangent of, in this case, our b over a. So that's how we're going to go through and find our angle to things, okay, as we go through. Okay, so we're going to go through and find this for a particular problem. So let's say, again, we have an initial point at -8, 1, and we have a terminal point at -2, -5. Okay. Well, step 1 is we want to go through and get the position vector. So get position vector. Okay? So in order to do that, remember, we just have to go through and subtract those parts. So I'm going to go through, I guess I'll show the steps in here. But we want to do -2 minus -8. And we have to do -5 minus 1. So we do -2 minus -8. Again, that minus negative becomes plus, so it's really -2 plus 8, which is 6. And -5 minus 1 is -6. So there's our position vector. Okay? Well, what that does is it basically puts it starting at the origin and then going up. So now, step 2, we can find our magnitude. Now remember, your magnitude is also the length of the line. So the formula for it is we do the square root of our x value from here, squared, plus our y value from up here. Oh, darn it, just put a little white. There we go. So this one's -6 squared. Make sure, especially if your number's negative, and when you square it, you are putting it in parentheses. So if I simplify that, I end up getting the absolute value of 72, which can break down. 72 is the same thing as 36 times 2, and the square root of 36 is 6. So What that means is, there's my symbol for it. Square root of 36 is 6, and then we have that extra 2. So there's my magnitude of it. Okay. Alright, what I'm going to do is get rid of the position vector part of it, and then we're going to find our direction. Okay. So I'm going to get rid of that. That way we're keeping most of it on the same page. Okay, so now we want to find our direction. And okay, so now if we go through and find our direction again, it's going to be the tangent of theta, and it's going to be our y value, okay, of our position vector, which actually I've already erased, which was negative 6 over 6, okay? And when we go through and do this, we want to do this in degrees, okay? So if I do the inverse tangent of negative 6 over 6, what I end up getting is negative 45. So it's negative 45 degrees. However, we want this to be between 0 and 2 pi, so we just add 360 to it, and what I end up getting is 315 degrees. Okay? So, if I go through, I'm going to get rid of number 2 here in a minute. Right, so we can take a look at what this would look like visually as a vector. Okay, so we know it's going to end up over here. We're going to go 315 degrees. So it's going to be over here. You know, we had changed it. So our position vector was at 6, negative 6. This is 315 degrees. Now, our length of it, okay, the length of our line was 6 square root of 2. So that's what this one would look like visually, okay, as we go through. Okay, so moving on. Alright, so let's say, for example, I have a vector 3, negative 2, and we have vector negative 1, 4. Okay? Okay, let's say if I wanted to do the addition of those two vectors. Well, it's kind of all you would really think that it is. All we're really going to go through and do, let me change color here a second, is just add the two x's and then add the two y values. Okay? So, if I look at the addition of these two vectors, okay, it'd be 3 plus negative 1, which is 2. And if we have negative 2 plus 4, which is a positive 2. So there's the addition of our vectors. Again, those are not 7s. Sloppy handwriting. Okay, if you want to do the subtraction, again, essentially exactly the same thing. Now we want to subtract them though. 3 minus negative 1, which is 4. And then negative 2 minus 4, which is negative 6. Okay. Alright, so now one of the things that I put in the notes was the graph of them, even though I'm not going to make you go through and graph a lot of these. So let's see what this actually looks like visually. Alright, so we're going to start with u. U is at 3, negative 2. Okay. So there's our vector for u. I don't know if I'll be able to write a u in there very well. Alright, now from its final position where our arrow ends, we're basically going to add the v. Okay, so it means our x is going to be negative 1, so we've got to go 1 to the right from our arrow, and then we have to go up 4. So 1, 2, actually I can't even see my own writing here. Negative 2, so 1, 2, 3, 4. So it should be right here. I believe I counted right. So there's our v value. Okay, basically what we ended up, oh, that's terrible. Let me see if I can redraw that. That is absolutely horrible. It's very hard to draw these, by the way, especially with your finger. Okay, 1, 2, 3, 4. 1, 2, 3, 3, 4. 1, 2, 3, 4. Okay, so I'm going to start that over. Alright, so let's see. U is at 3, negative 2, so I had to go over 3 and down 2. Looks like it's going to be right. Point very well. There we go. So we're at 3, negative 2,
we have to go, now to add our v, we got to go 1 to the right. So that's going to put us at 2 on our x-axis, and we have to go up 4. So 1, 2, 3, 4. Gosh darn it, should be right. It doesn't let me do dots very well. So there's our v value. There was our u value. And what our new vector right here represents is that addition of the 2 right there. Okay, that's part of it.
If we're looking at the subtraction of the 2, our u value is still going to be in the same location. I have to make this thing go down a little bit. So we're going to go over 3 and down 2. Just going to put us right there. Okay. So there's our u value. Okay. Well, now, in order to subtract
This, we have to subtract -1, which means we're going to be going to the right one. And then we have to go down 4. So we're going to have to go down another 4. 1, 2, 3. It's going to put us way down over here, a little bit past it. So there's our v value. Okay, it's basically a negative v is what you're doing. And so if you were to connect those two, that right there is actually the subtraction of them. Well, like I said, however, I'm not going to make you do a bunch of those anyway. So, all right, moving on. Scalar multiplication. Okay, so scalar multiplication. Alright, so I'm going to leave for this one with an example because it's not something that's extremely difficult. Okay, so let's say we have this vector at 3, 1. Okay? Let's say if we wanted to find 3v. Basically what you're doing is you're just multiplying each part by 3. So this would be at 9, 3. Or if you're wanting to do like, half of v. Well, half of 3 is 3 over 2 or 1.5. I don't care how you write it. Same thing, half of 1 is 1/2 or 0.5, however you want to write it. And just like if you were to take a negative sign, okay, all you do is just take the negative sign, so it would be -3, -1. Okay, so don't overcomplicate scalar multiplication, just means that you're multiplying each part to them. Alright, next. Okay, so you can also have ones that you're doing a little more work to. So let's say I have 3, -2, and our v is at -1, 4. Okay? And let's say that we wanted to come up with a new vector, w, that's 3u plus 2v. Well, what you end up having to do is multiply everything in u by 3. So that puts me at 9, -6, plus, now I got to multiply each thing in the v by 2. So it'd be -2, 8. Well, and then from there, we just add the two vectors, which we've done previously. So 9 and -2, which is 7, and then -6 and 8, which is 2. Gosh, I've never been good at writing those. I'm going to try to make those a little clear. It's more of a angle that comes down. It's more like this. I just make mine end up looking like a 7 more than anything. Okay. So, moving on from those. Alright. So, if we want to find the component form of something, okay? Okay, so, component form. Okay, so finding your component form. Your horizontal is dealing with your x, and your vertical is dealing with your y, which is not, something that's unfamiliar to us as we go through. So, we find the components of a vector. If we have our initial point and terminal point. If you're looking at a horizontal component, I have hiccups. Horizontal component. And basically what that means is that, you're moving on your x, okay? So you're going to have a number here and then 0. Okay, it's basically how much you're moving to the right or to the left. If you're looking at a vertical component,
you basically have 0 here, and then you're going to have your number to it.
Okay. So one of the things, I'm not going to spend a ton of time on that, but one of the things that we do have to go through and do is find a unit vector. So I'm going to go ahead and start looking at a unit vector a minute. Alright. Unit vector. Okay. So unit vector is basically in the same direction, and it has a magnitude of 1. So if you're looking at a vector and it's unit vector, it's kind of like the unit circle. You're just looking at a 1 unit version of it. Okay. Now your horizontal, okay, unit vector is going to deal with I, and your vertical is going to deal with your J. Okay. So just kind of know, because those are going to pop up here in just a minute. And basically your formula, come on, write this for me. Your formula for unit vector is your vector over the magnitude of that vector. So we're going to go through and do, some examples of this so that you guys can go through and find a unit vector. Okay? Alright, so let's say, sorry, I had to pause that. My kids came out. Alright, so let's say we're looking at the vector, oh gosh darn it, come on, write for me, -5, 12. Okay? And let's say I wanted to go through and find my unit vector. Well, first, I'm going to have to find the magnitude. And our magnitude number is this symbol, which is the bottom of our fraction as we're starting to find it. So remember, all we do is just take our x value squared plus our y value squared. Okay. So in this case, it gives us 169, which happens to give us a nice number of 13. Okay. So now, basically, what we're going to be doing is dividing each of these parts right here by our magnitude, because there's our vector, and there's our magnitude. So there's a couple different ways that you can write this. You can write it as -5 over 13i plus, in this case, 12 over 13j. Okay, that's one way you can write that. You can also just write it as a unit vector this way and do -5 over 13 and 12 over 13. I don't really care either way. Both ways actually work. Okay, so moving on. Okay, so we're going to kind of talk briefly about these. Okay, so let's say if you want to write something in terms of I and j. Let's say I had an initial point at 2, -6, and a terminal point at -6, 6. Okay? So if I wanted to write this in terms of I and j, my horizontal and my vertical, for my vector, all I have to do is just go through and subtract, just like we had before, -6 minus 2, which is -8. Oops, I don't really need the parentheses. I'm not going to show those steps. So that'd be -8i. And go through and subtract these. 6 minus -6, which gives me a 12. And that's j. Okay. So don't overcomplicate those. Those are not too terribly difficult. You can also have, basically, I have the rules in the notes that I sent you, so I'm probably not going to spend a lot more time on those, per se. Okay, so let's go through. Sorry. And we're going to calculate the component. Form of a vector. Okay, so we'll start out generic. Let's say given a vector x and the direction is equal theta. Okay. So our cosine of theta is your x value over your length, okay, which is your magnitude. And the sine of theta, and I think back to looking at a graph on, would be your y value over your magnitude. So technically, if I were to get these in x equals, this one is x equals, our magnitude cosine of theta, and y is the same thing as our magnitude sine of theta. So technically, what we have is we have our x and we have our y. Okay? So what we could rewrite this as then is instead of writing x, we could write the magnitude of cosine of theta plus the magnitude sine of theta. Okay?
So basically what we're doing is we're basically just finding that part to it. Our magnitude is still going to be the same as it was before. So we're going to go through it and write some of these things out.
Examples.
So let's say, for example, we have a vector with length of 7 and an angle of 135 degrees. Okay. We want to write this in terms of the magnitude and the direction. Okay. Well, remember our x is our magnitude, cosine of theta, I, and our y is our magnitude, sine of theta. Okay. And it deals with our j value. Well, if it has a length of 7, that's our magnitude. And we know what our angle is, so 135. Same thing with our y. We know what our cosine of 135 is, okay, which is just negative square root of 2 over 2. So if I multiply that with the 7, I'll end up with negative 7 square root of 2 over 2. And my sine value is positive square root of 2 over 2. So if we multiply that by 7, we get 7 square root of 2 over 2. Okay. If I wanted to write that in terms of I and j, it would be negative 7 square root of 2 over 2I plus 7 square root of 2 over 2. Okay, so we're just going through and writing that in terms of I. Now, there are going to be times where we don't actually know, what our angle is, and we're going to look at one of those here in just a second. That I have a vector who travels from the origin to 3, 5. So it goes from 0, 0 to 3, 5. And I want to write this in terms of my magnitude and my direction. Well, if I want to go through and be able to find, all we're going to do, the x value, because we're looking at a terminal point, squared, plus 5 squared, which is going to give us the square root of 34. Okay. We have that. Well, we don't know our angle, so remember, our tangent of theta is our y value over that x value. So if we do our inverse tangent, and again in degrees, I get 59 degrees. So my x term is my magnitude, which is square root of 34, cosine of 59, I, and my y value is the square root of 34, sine of 59, j. Okay? So we could write that vector out. I'm not really going to have a lot of space for it, but 34 cosine of 59 I plus square root of 34 sine of 59 j. Okay? Alright. Now we're going to go through and look at dot product. Alright, dot products. Okay, if you're looking at your dot product of it, essentially, let's say if I have A and then B
and then I have a different vector at C and then D. Well, all you really do, dot product is your multiplication. That's all you're really going through and doing. So what you end up doing is multiplying the two x versions. So if we were to multiply these two together, it would be A times C and then B times D. Okay? Or sorry, plus D. I can't read that. Just read that. Sorry. It is the multiplication of these two plus these two. I'm starting to write all kinds of extra symbols that I didn't need to put. We're just multiplying our A and our C plus our B and our D as a sum. If we want to find the angle between the vectors, so the angle between, angle between our vectors is going to be the cosine of theta equals our vector over their magnitude times the magnitude of, that is a U. Magnitude of vector. Okay? So what we're going to do here in a little bit is we're going to find the dot product, and then we're also going to find the angle between two vectors. So there are times where we are going to have to go through and multiply two things together. So let's just say if we're going to do a dot product, let's say we have B is at 5, 12, and U is at negative 3, 4. Okay. All I need to do with these is multiply these two together. So 5 times negative 3 plus, and then multiply these two together. 12 times 4. So that gives me negative 15 plus 48, which gives me 33. So there's my dot product, or my multiplication of the two. And there's a couple of those in your homework. Okay, so now we're going to find, we're not going to do that other example. Let's do this one. Okay, sorry, coming on back. My kids came out being loud. If you hear screaming in the background, it's one of their video games in their room. I can hear from here. But anyway, we're going to find the dot product of these two. Again, we just multiply the x's plus multiplication of the y's. So in this particular case, I end up getting 15 plus 14, which gives me 29. Okay, so there's my dot product. Okay, well, now I need to go ahead and find these magnitudes to it. So my magnitude of the first one is the square root of 5 squared plus 2 squared, which gives me the square root of 29. And then my magnitude of vector 2 is going to be 3 squared plus 7 squared, which comes out to square root of 58. Okay, so now, like I was saying earlier, our cosine of theta is going to be our v over our magnitude of v times our other vector over the magnitude of that vector. So what I end up getting is I have my initial first vector, which is 5 over the square root of 29, plus 2 over square root of 29 times 3 over the square root of 58. Oh, gosh darn it. Try to fix that. Plus, sorry. 7 over the square root of 58. Now, in order to do the multiplication of these two, again, what I'm going to have to do is multiply these two plus the multiplication of those two. So I'm going to try to write this the best that I can here. So 5 over square root of 29 times 3 over square root of 58 plus 2 over square root of 29 times 7 over square root of 58. Well, now, if we multiply across, we get 15 over the square root of 1682 plus 14 over square root of 1682. See, I'm running out of room now, which comes out to 29 over the square root of 1682. Alright, so now, basically what we did was we found what our cosine's equal to. Now we have to find our angle measure to it. So I'm going to get rid of some of this stuff from over here. Try to get this out here. Okay. Alright, so what that means is our cosine of theta is cosine of theta is this 29 over the square root of 1682. Okay. Alright, which if we simplify that number instead of writing that, cosine of theta is about 0.707. Okay. Well, if we do the inverse cosine of this, come on, quick. I ended up getting 45 degrees. Okay, so basically, let me get rid of some of this over here. So basically, visually what we have, that's enough room. Visually what we have, okay, so we have one vector that went to 5, 2, and we have another vector that went to 3, 7. And what we were able to do was find the angle between, which is 45 degrees. Okay. Okay. So I put one last example of that. It's kind of hard to write all that on here, but one last example of that on your notes. So hopefully that helps. Kind of let me know, what you think. I know this area does not work the best because I have to write it out and it's really sloppy, but hopefully that helped a little bit.